Hey guys, in today's video we're going to have a look at the factorization law, which is used in simplifying algebraic equations. And after going through the law, we'll have a look at a few basic examples applying it. So first let's have a look at the law. So it basically says that AB plus AC equals A outside of B plus C. And if you're thinking this law looks fairly familiar, you'll be correct, because going from left to right, it's called the factorization law, but going from right to left, it's called the distributive law, which we looked at in a previous video. And the distributive law is used for expanding the brackets to get each term individually, whereas the factorization law is working backwards to go from the individual terms into a common factor out the front, followed by the rest of the terms without that common factor. So essentially what we're doing in the factorization process is removing the highest common factor out of each of the terms and writing it outside the front. So let's have a look how it works by going through a couple of examples. It's probably the easiest way with this law. So let's say we have the equation 3p plus 9, and we wish to write it in terms of some kind of brackets with two terms and a component outside of the brackets. So the first thing that we do here is look at each of our terms, in this case we have 2, and see what's common amongst the terms. The first term has a p, the second term has no p. So that means that we cannot remove a p from the first term. The p has to remain in the first term, so we could write it there. However, both terms have some kind of number, which in this case, 3 in the first term, 9 in the second term, we can see there's a common relationship between 3 can go into 9 3 times. So the highest common factor in this equation is the number 3. Both terms have some multiple of the number 3. The first term has 1 3. The second term has 3 3s. So what we can do is take out a 3, which leaves us with p plus 3. And the way that we can check whether we're correct here in our factorization is using our distribution law or distributive law to work backwards. As, like I said, remember they're inverses of each other. So, multiplying the term outside the brackets with our first term, 3 times p, will give us our first term, and multiplying the term outside the brackets with the second term inside the brackets, 3 times 3, you can see that we do in fact end up with 3p plus 9, which is the same as our original equation. So, in this case, we applied the factorization law correctly. So let's have another look, or let's have a look at another example quickly. 8a plus 2b. So how do we factorize this? So once again, we have a number in each term. So more than likely, we're going to be able to take out some kind of number component. The first term we have an a, the second term we have a b. So this time, unfortunately, we can't take out, once again, a common variable. So we're at least left with an a in the first term in the brackets and a b in the second term. But once again, we can see that we've got a highest common factor here because 2 goes into 8 4 times. We can take out a 2, which leaves us with 4a plus b in the brackets. So 2 times 4 is 8, 8a. 2 times b is 2b. So it takes a bit of practice, but you can always determine whether you've been correct by working backwards using the distributive law. Let's have a look at one more example. So here we have 24p cubed minus 12p squared. So how do we simplify this time? Let's do it a little bit more quickly. Both terms have a multiple of 12. 12 goes into 24 2 times. 12 goes into 12, or negative 12, negative once. So we can take out 12 outside the brackets. So what does that leave us with? In the first term, it leaves us with 2. Plus something to do with p, which we'll come back for. The second term leaves us with 12 times what? Gives us 12, it's negative 1. So negative 1. And let's have a look at the p terms now. So both terms in this equation have a p. The first one has p cubed, the second has p squared. So there's at least a common factor of p squared. So by taking out p squared, we're left in the first equation with just a p. P squared times p is p cubed. And in the second equation, we're left with nothing. So if we were to rewrite this, just tidy it up a little bit, we can be left with 12p squared outside of 2p minus 1. And that's our answer. So that's the basic factorization law used for simplifying algebraic equations. There is a little bit more of a complex factorization law, which we'll look at in a later video. But essentially you can go from an algebraic equation such as this, x squared plus 5x plus 6, straight from this into something like this. But like I say, we'll go through that in another video. Thanks for watching, guys. Make sure to leave some questions in the comments below, and see you guys next time. Bye.